All right, so we did not get to problems like 12, 13, 14, 15. These problems at the top of this page in our review today, and I wanted to get to these with you in class because I really need to explain something about them. But because we went back over part of that other worksheet, we did not. So what you are using in these problems is called the Pythagorean Converse, or the converse of the Pythagorean theorem. It basically means we're using the Pythagorean theorem backwards. Instead of saying, I know this is a right triangle, so I know that a squared plus b squared equals c squared, we're asking what kind of triangle is this? Like I know some of the sides, I know 3 sides. What kind of triangle would it make? Well, we know that if a squared plus b squared equals c squared, that's a right triangle. That's the converse of the Pythagorean theorem. Because the Pythagorean theorem says if it's a right triangle, then this is true. So going backwards says if this is true, then it's a right triangle. But it goes beyond that. The other 2 things you can say with this are if a squared plus b squared is greater than c squared, it's going to be an acute triangle. And if a squared plus b squared is less than c squared, in other words, if it's not equal to, then it's either bigger than or smaller than, it's an obtuse triangle. The easiest way to remember which is which is by looking at c, looking at things from the perspective of the c squared. You look at the biggest side and you compare it to the other ones. If the biggest side squared is smaller, that's what this means. If it's smaller, it's acute. And that's why I like to look at it this way, is because we think of acute as meaning small, and we think of obtuse as meaning big. So if c squared is bigger, it's obtuse. If c squared is smaller, it's acute. Let me show you what I mean by that. Let's say I have 3 sides of a triangle, and those 3 sides are 2, 10, and 11. And I'm told that I have these 3 lengths. And I'm asking if it's a right triangle, an acute triangle, or an obtuse triangle. Well, first off, we know that the longest side is the hypotenuse if it's a right triangle. So if this was a right triangle, this would have to be the hypotenuse. So that automatically becomes my C. So that means these 2 are A and B. It doesn't really matter which is which. So a squared plus b squared here would be 2 squared plus 10 squared, which is 4 plus 100, which is 104. So I do a squared plus b squared, and then I come over here and I do c squared. So c is 11, so c squared is 121. This is what I'm comparing, these 2 numbers. If the c squared is bigger, right here, that's obtuse. C squared is bigger, it's an obtuse triangle. If the c squared was smaller than this number that's a squared plus b squared, it would be an acute triangle. So looking at number 12, we have 15, 18, and 20. So I'm going to take the 15 and the 18 as my a and b. 15 squared plus 18 squared. And I actually don't have a calculator, so hang on one second. 15 squared is 225. 18 squared is 324. So this becomes 225 plus 324. 225 plus 324 is 549. So that's what my a squared plus b squared is. Then here's my c, 20. I do c squared. 20 squared is 400. So what I'm comparing here is I'm comparing the 400 to the 549. Since the c squared is smaller this time, I call it an acute triangle. If c squared is smaller than a squared plus b squared, it's an acute triangle. If c squared is bigger than a squared plus b squared, it's an obtuse triangle. So your best bet right now is to hit pause on your video and try 13 and 14 and see if you can get those right. Okay, if you didn't hit pause, or if you did, moving right along. For this one, it's 7 squared plus 8 squared is my a squared plus b squared. That's 49 plus 64. And when I add those together, I get 113. So 113 is my a squared plus b squared. You could write a line if you want. And over here we have c squared. C squared is 11 squared, that's 121. Since 121 is bigger, the c squared is bigger, that's obtuse. Remember, if they were equal, we would say it's a right triangle. If they were equal, we would say it's a right triangle. And in this case, not only would it be a right triangle, but that would be a Pythagorean triple because these are all whole numbers.
3418. Christy Matthews.
Number 14.
Please call 3418.
If you're trying to figure out whether this is bigger than these two or not, the easiest way to figure it out, because remember the biggest side has to be the c squared, is to put it in your calculator. Now if you're using these kind, if you do it 3 times square root of 13, you might get, yeah, this is going to give me a math print answer. It's going to just say that's 3 root 13. If you look at mode, go to mode, at the bottom it says math print. That means simplified radicals. If you change it to classic, it's going to give me decimals. So now if I do 3 times the square root of 13, I get a decimal. So that's 10.8. So that's definitely bigger than 6 or 7. So they are putting these in order. So this is the c still. So 6 squared plus 7 squared is 36 plus 49. Put those together, you get 85. Now here's the part that I thought you might want to see, is when I square 3 times the square root of 13. Let's look at that sort of separately here. Get some more room. 3 times the square root of 13 squared means that times itself. Okay? What's going to happen here is remember that you can multiply children outside the house with other children outside the house, numbers outside the radical. So that's 3 times 3, that's 9. And then children inside the house times other children inside the house, 13 times 13, that's 169. But 169 is 13 squared. What you'll get anytime you multiply a square root times the same square root, excuse me, you're going to just get that number. Square root of 13 times square root of 13 is just 13. Okay, so I did 3 times 3 is 9. 13 times 13 is 169 under the radical. Square root of 169 is 13. So 9 times 13 is 117. So when I do c squared here, I get 117. And 117 is bigger than 85, so this is an obtuse triangle. Again, if you have not paused and looked at number 15, you might want to pause now and look at number 15 and see if you could figure out the answer to that one. Okay, looking at number 15, it says Kitty has a triangle with sides that measure 16, 8, and 13. She does some calculations and finds that 256 plus 64 is greater than 169, and so she concludes that the triangle is obtuse. Evaluate her conclusion and reasoning. Her conclusion is wrong because what she did wrong is that she said 13 was the longest side. She squared 13 by itself on one side. Remember, the one you put by itself on one side is the longest side. That would be the 16. So we would go 8 squared plus 13 squared and then compare that to 16 squared. So it would be 64 plus 169 and compare that to 256. And I think the 256 is probably going to be bigger. So that would actually be obtuse. Actually, it would still be obtuse, wouldn't it? Or is that bigger? Yes, it is. So her conclusion that it's obtuse is still right, but 169 and 64 are the two numbers we would add, not 256 and 64. If you want to go ahead and do some more practice on this, you can find some. I will go ahead and put some on the webpage and answers. So I'm going to give you a web page where you can go to get some more practice on this and show you where to find the answers.